Hello, can you hear me? Hello?
Yes, sir.
Yeah, sorry for the disconnection. Okay, so so for this data, what dot values is trying to do, convert dot values, is just to get the values, the actual values in the data. So if you have your data in a data frame and you want to get the features in a NumPy array, just call the data frame. This convert is my data frame. When I put dot values, it will give me the values inside the whole data frame and take that as my features. Because you cannot use the data frame directly to build your model. You have to convert them to a NumPy array. So that's why we use the dot values to get the values there. Then what I'm doing here, I have the target variable called the treatment. I showed you last class during a breakout session on, or not last class, many classes behind, how to convert a categorical variable to a numeric variable. And one of the students said, oh, I showed it two different ways. The first one I showed you was using the pandas attribute, like the pandas method called the get dummies. So that's what I would use here. So this line, I'm trying to encode the categorical variable into a numeric variable. So I use the get dummies, then I pass the treatment column there. I showed you what this drop first equals to true means. So it will make sure that you have a single row, not a single column and not two columns of the two classes in that variable. In this way, I have the CSM and the hands-on. Then I save it in a new variable called treatment_cat. Then you can check the head. So you can see the original column, the original variable treatment, and the encoded variable called treatment_cat, where 0 stands for computer simulation method, CSM, and 1 stands for hands-on. Okay, so that's my Y, the Y column. So I selected that and save it as Y. So I just wanted to show you the first 5 here, and those are 0001. So that's just the first 5. I just wanted to show to be sure I have the Y and the X. So I have X here. You can even check the X too. You can check the X, maybe the first 5. So you can see these are the first 5 rows of my X. So this is a NumPy array now. You can see it's no longer in a data frame because I did dot values of it. Okay. So when I've done that, I want to split my data. I've not applied PCA. I'm still doing all of the same thing we have been doing before because your data has to be in the right format before you apply PCA. So let's split the data. From scikit-learn model selection, I import train text split. So I want to save it as xtrain and x text. Then I have y train. Then I have y text. Then I put my train text split, my train text split. So I want to split my x into x train and x text and split y into y train and y text. I showed you a concept called the stratify the last time. So I'll put that as y. What stratify is doing is that it's ensuring that when you split it, the same number of targets, the same number of y's, these zeros and one are distributed equally to the train and test. Because sometimes if you don't do that, you will have higher number of zeros in one and higher number of ones and lower number of ones in the other. So to make sure that they are distributed equally, you specify the stratify to be y. Then I also want to set the seed as a random state. I like using 0. Then let me check the dimension of the split data. So x train, the shape, and then x text, the shape. So I have 252 rows to train, but still 2,150 variables to test as my features. So I want to now reduce the dimension of the data. So how do you do that? You first get the function, the package, or the algorithm from his class. So we are using from scikit-learn decomposition, import. You can even press tab, it will show you. So we have PCA, we even have fast PCA. Yeah, we have ICA, called the independent component analysis. That is also another principle, another dimensionality reduction. There are a couple of them. Okay, so here I want to create an instance of my PCA. I name the PCA. So PCA, then I want to use, out of 2,150, I just want to use 150 of them. So n components. Let me use 150. So I'm using 150 principal component. That's the new directions, the new features that we summarize the most important information in the original data. Okay? Let's check other hyperparameter, but the n component is the most important parameter. Okay, so we also have the random states. So I can also set it for reproducibility. So let me put 0. So here we've only created an instance of the PCA. Then here I want to fit it. Let me save my variable as string PCA. So I have, this is my PCA. Fit, remember I told you that just calling fit, we only center your data to have a mean of 0. So we call it fit transform and pass your training data there. So we also do that to the testing, but you only transform the test. You don't fit transform, okay, the test data. So we have the PCA dot transform, then we have our text data. That's all. Let's check the shape of the new one. Let's check the shape. So I'm using xtrain PCA, xtest PCA. Let's check the shape. So now you can see it's no longer 2,150. It's now 150 because I specify that I only want 150 directions that will help, that will give me that will help me summarize the data. So suppose I want to build a machine learning model, let's say any classification model, I can go ahead now. I already have, so you'll be using the xtrain PCA as your training with the y-train and then xtest PCA as the test set. So I can go ahead now and build a machine learning model on it, like maybe k-nearest neighbor or support vector machine or random forest, but you will be using, you are no longer using the previous xtrain. All you'll be using is the xtrain PCA with the y-train, and then you test it on xtest PCA and the y-test. Any question before we move to the tasks we have for today in the breakout session? Any question? Any question, please? Are we good? Okay, so in the absence of question, all I want you to do, I put a data in your Canvas dashboard called the glass data. So though that data doesn't have so many dimensions, but there is a classification problem. Like the goal is to tell the type of glass. There are just two types there. The type of glass based on the amount of other elements present. Meaning there are elements, all these first 20 elements we did in secondary school, sodium, magnesium. So there are a couple of them there, maybe like 6 or I think 9. So, but the dimension is not so large, but I want you to apply PCA on it. So explore the data to check the dimension, check for any missing value. I'm sure you don't have missing value. Find the number of principal components required to classify the glass type. How do you do that? When you find the principal component, find the explained variance ratio. I could do that here too, like X train, PCA. Oh no, where I did my PCA, where I instantiated my PCA. If you press tab, you see the explained variance ratio. Do sum, and then to find, so you can see, just picking 150 variables out of the 2,150 gave me, was able to explain over 99%, 99.9% of the most important information in the data, meaning over the remaining 2,000 are just waste. So it's so large, but they are not really telling us anything. So 150 variables was able to do the job of 2,150. So that's what I want you to do. So you can check different number of dimensions, but check their explained variance ratio to see the number of percent they are contributing to the data. Okay, so when you do that, visualize the first two, because the principal components are arranged, they are sorted in order of importance, like doing this kind of visualization. This one, this is just the first two. So visualize it, and when you visualize it, then build a machine learning model. Choose any model, any classification model of yours. It could be random forest, it could be support vector machine, it could be gradient boosting, it could be XGB boost. Just build a machine learning model on the reduced data. I'm not going to tell you the number of dimension, the number of dimension you should reduce to. That's why I said find the number of principal components using the explained variance ratio. Okay? So that's the task I want you to work on.